another but important topic. That's like ground and safety. I just put everything in this chapter here. So what is important here? So like there's a lot of stuff. If in doubt, like consult a professional electrician. I'm just a computer scientist. I'm not the authority here. I'm just giving you an overview. So first and foremost, we got ground. Ground is like the neutral stuff. So you got like your power supply, there's voltage, and it comes back to ground. And there might be like multiple power supply. And the most important rule, if you just take one thing from this, connect the ground on your power supply. So on the DC side, so on the not on the AC side, but on the DC side, connect all grounds at the power supply, and ideally only at the power supply. And that has multiple advantages, which are sometimes a little bit tricky electronically, but just do this there. It's important for safety, otherwise this might actually kill you. So bad things may happen, really. Do it. There's no if and do it. Just do it. Then you should run like separate grounds to your playfield. I've seen people running like one ground, then 48 volt, 5 volts, 12 volts. And then they all share the ground back. That technically works, but as like any wire, like this one, has a resistance, then like your wire where the voltage goes into the playfield has like less resistance than the ground where it comes back. And that's an issue. That will cause problems. Additionally, like it will cause like interference between the voltages, so don't do that. Run like one power in 12 volts, one ground in 12, into the 12 volts, right? Then 48 volts in, 48 volt ground. Connect those at the power supply here. That's important. Just keep one thing, do that. Yeah, like same number of grounds than power. Then you got earth. Earth, like I like sometimes it's also kind of protective ground. I think in the US they call it protective ground, but that's something which is like a safety feature. It's only there to protect against faults. There shouldn't be any current flowing on Earth. It's just for protection. So your power is going in on the plus and then back to ground on minus. And Earth is just next to it. And in a pinball machine, you typically connect like ground to Earth at the power supply or even in the power supply. Most like switching power supplies like mine, they are connecting ground to Earth. And there shouldn't be any current on Earth. If there's current, your circuit breaker in your house will trip usually, the RCD will trip, because that's what it detects. It detects if there's current flowing on Earth. If, then it will cut power. There are also like different ways to wire Earth, but even if that's like not the case, it protects you by, I mean, if there's like some voltage somewhere, it goes to Earth, then your fuse will burn because basically because power is flowing through Earth. That's the second like safety feature of Earth. But your take is just connected at the power supply. That's important. And I guess that's also like valid in any country. So that's the rule. If you want to have a pinball machine and put it to a location somewhere where humans other than yourself are touching it, those are really important safety rules. Next thing is like something which is a little bit more into general safety concepts and grounding concepts. It's appliance classes. And appliance classes is something which is related to like building a device. And that's like not everything of device safety, but electrical safety. And this is my personal advice. If you even want people to play test your machine, do this. It's important, right? The idea of appliance classes is that a single fault cannot cause harm to humans. That's or like or cause like electric shocks, right? That's the goal here, and that's achieved in machines which have like dangerous voltage, by connecting all conductive parts which come out of the machine. So in a pinball machine, that would be everything which is like conducting parts like metal, which comes from inside the cabinet to outside. That needs to be connected to earth for like the reasons I mentioned before, that if like any like, for example, high voltage cable on your coil comes loose and it connects to the rails on your cabinet, that might give you like a human an electric shock. But if it's connected to earth, then it will go to the rail, and the rail will be connected to earth. That should trip the RCD or the fuse, and then that's basically prevented. And that's the basic idea of appliance classes. In appliance class 1, that's what typical pinball machines are, as this general rule. And this applies to all high voltage parts. In some, or like in most parts of the world, 48 volts do not count as high voltage. So that's low voltage for several reasons. But if you got AC in there, then this definitely applies. If it's only 48 volts, then you might, like in modern Sterns, they got AC in the back box only. So only the back box is like appliance class 1, and the cabinet below has like less requirements because it has only 48 volts. And that's not dangerous by law. But personally, especially like in a homebrew machine, I would do this anyway in the cabinet. But like I'm not a legal expert here, so just giving you like the idea where this is coming from, why it's done, and why like all those big brass wires actually are there in your pinball machine or in most pinball machines. That's the reason. Okay, then we got fuses, so that's important stuff. Typically you got like 2 types of fuses. The first is like your AC fuse, that's before your transformer or power supply, and then there's like a second fuse per voltage after your power supply. So one for 48 volts, for 5 volts, for 12 volts, and so on. And this is basically for fault isolation inside your machine. And that if something shorts, it will not burn, right? So the idea is to prevent like fire hazards, also like prevent electric shocks, but especially fire hazards on the DC part. On the AC part, it's basically to prevent faults in your power supply. In general, like use a fuse which is less than your maximum current. So if you got a fuse which is like 20 amps, but your power supply can only output 15, then it will never trip, right? So it needs to be smaller. And sometimes there will also be like one fuse per bank of coils, so like 8 coils and then one fuse. It's also nice, and you can have better fault isolation, but technically like it's not needed for safety, right? It's just better for debugging, and maybe it allows you smaller fuses as well, so that maybe a little bit of safety, but in general more like a maintainability. And this is basically how this should look, in my opinion. Again, I'm not a professional, but my opinion here. This is your AC, so here's your wall plug, one fuse, then your power supply or transformer. Then here you got like 48 volts. They are like the minus pole, the ground pole, the ground connector is connected to earth for like, again, this electrical safety and RCDs and so on, and appliance classes. And then you got like a fuse again, and then here you got your coils or whatever, or your boards. So that's simplified now. But that's the general idea with fuses. And that's already what I got on ground and safety.